side of things would be, why do we have an overload relay and a fuse, or a miniature circuit breaker in this case? Well, it would seem on the first instance that they both fulfill the same function. However, there is a difference. The circuit breaker or fuse will protect against a short circuit. That would be a cable coming loose, going to ground. It could be two wires touching each other, and then it would immediately disconnect the supply to the motor and prevent large current surges. The overload relay in this instance would protect against incremental overloads, small overloads on the motor, increasing the current draw and subsequently the motor heating up and potentially causing thermal damage, burning out, so on. This would typically happen if we had one, so we would say lose one leg or one phase to be disconnected by some means. Perhaps there's a failure here in the contactor, and these two contacts close and this one doesn't. And in that case, we would lose one leg. Now, what that means is, if this is a 15 amp motor, for example, the current is shared between each phase. So we would have 5 amps, 5 amps, 5 amps. But if we lost this leg, then we would still pull 15 amps, but this would be shared between two phases. So we would now pull 7.5 amps and 7.5 amps. Now, the cables may not be rated for such a current, and the motor would certainly run in an unbalanced way, potentially heating up and potentially failing prematurely. So in summary, the overload relay is for overloads, either as described through electrically, or if the bearings are seized or we have additional load on the motor, for example, an obstruction in the pump or whatever it's driving, and that will trip the overload relay. And also we have the fuse or the circuit breaker, which will prevent against large currents caused by short circuits.